So in this session, I want to write code for the last index problem. Okay. So we have already seen how we are going to write code for this. So let's quickly jump to code. I'm just going to brief you again. So first of all, the base case will be if length is 0, I'm going to return -1. And to start with, I'm writing code for copying the smaller part. I'm not using start index. I'm going to copy the smaller part and I'm going to use that. Okay, so if length is 0, I'm going to return -1. If length is not 0, in case the length is not 0, then I'm going to call on the smaller part first, because if there is an x here, I will give preference to that rather than if there is an x here. Okay, so I'm going to first call on the smaller part. If that returns -1, then I'm going to check on the starting element. Okay, so let's quickly write code for this. Okay, last index, my list and my element x. Okay, so let's get the length of a. In case length is 0, you can return -1 because there is no element present in empty size list, so you can just return -1. Okay, so if I'm done with this and I've reached this place, that means my list has at least one element. Okay, now we'll first create the smaller list, check on the smaller list, now the smaller list has given its output. So this has given the output. In case this returns a -1, I will have to check here. In case this returns a 3, what does that mean? That means that you have x at index 3 in the smaller list. So you need to add +1 corresponding to this element. Okay, so you'll have to add +1 corresponding to the element that you have removed. So if smaller list output is not equal to -1, then I'm going to return smaller list output +1. Else, what does else means? Else means it is -1. If it is -1, that means it's not in the smaller part. So I need to check if a of 0 is equal to x. If you have x at the 0th element, now you don't have x anywhere else. So if you have x at the 0th element, then you need to return 0. Because that's the first as well as the last index of x. And in case you don't have x here as well, in case you don't have x here as well, then you return -1. Okay, in that case you can return -1. Let me create a list. Okay, x is 4. Let's return the last index of x. Okay, seems like we did something wrong. Seems like recursion depth exceeded. So there is something wrong which is going on. Let's just see what happened here. Oh. Okay, so seems like the error is that we are using a here. We are calling last index on a. We had to call it on smaller list. We have to be careful about what we are doing, right? So now you get index 7 as your answer. So let's see. Index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So yes, this was the last index where 4 was present. Seems like this is working fine. Right? So let's see how it worked. So let me take a smaller example for our dry run. Okay, so I'm going to take this example, and this should return 0, 1, 2, 3. Okay, so it's returning 3. So you have 1, 4, 5, 4, 8, and you're looking for 4. So as soon as you come here, you check the length is not 0 for sure. So you make a smaller list and you call 4 on this. The length is not 0. There is 4 at index 0. No, you don't worry about that. You are not checking a0 being x till later. So we are not going to check for this element. We are going to call on 548 looking for 4. It's not going to check if 4 is present here. It's going to call on 4, 8 with a 4. Now you have a 4 here, but it's not going to look at that. It's going to make another call at here. Then this is going to make another call to empty array and 4. Now empty array will say, hey, the length is 0. I'm going to return minus 1. So it returned minus 1. So you got minus 1, right? So you went here. You checked if a0 is x, but it's not 4. So you continue returning minus 1. So this function got minus 1. So this also came here. Now it's checking if a0 is 4, which is 4. So you return 0 and you don't return minus 1. So you're returning 0 from here. This function gets something which is not minus 1. So it adds 1 and returns it. It returns 1, this returns 2, this returns 3, and that is the correct answer that you were looking for. Okay? So the difference between finding the first index and last index is there we were looking at the 0th element first and making rest of the call. Here we are making the call first, and whatever the answer is, depending upon that we are deciding if we need to check for the 0th element or not. Okay, that's how this function is working. Perfect. Now I'm going to code it again, and this time we are not going to make a copy. And by now I'm hoping we are really good at doing this, so I'm going to be a little fast. So last index better, we get the list, we get the x, length is equals to L is equals to length of a, and we also get the start index, right? We get the start index as well. So now if start index is equal to L, that means you have nothing left, there is no element left, so you can return minus 1, right? You can return minus 1. We don't have to create the smaller list, so we will directly call smaller list output. So we are planning to check for the 0th element later. We are not checking right now. Last index B will pass A, X, and SI plus 1. SI plus 1. Okay. Now the code will be very simple. If smaller list output is not equal to minus 1, that means so my list I called here, and this one is saying, hey, I have found something. But this time I'm not going to add a plus 1 to this, because it's going to return the actual index in the complete list, not just this part. So I'm not going to add minus 1. In this case, I'm going to return smaller list output, else, wow, I have received minus 1. That means you couldn't find x anywhere here, right? Okay, let me just do this again. So this means I got a call here. I have called on this part. I couldn't find x anywhere here. So now I'm going to check at this particular index. So if we are getting minus 1, so there is no x here. If there is no x here, you need to check at the SI element as well. So if a of SI equal x, you return SI, else you return. You didn't find it in the smaller part, you didn't find it in the beginning element, you didn't find anywhere, you return minus 1. Right? You return minus 1. I think this should work. Let's print this. Let's also print last index better. Comma x comma 0. And this works fine as well. Okay? Let me dry run this for you. The second one. You have this. This is your list. Your element that you are looking for is 4. Start index is 0. As soon as you come here, start index is not equal to the length. So you make another call, and this time you're looking for 4, you pass it 1. Again you're passing the same array, but you are saying start index 2. Still the start index is not equal to length, so you make another call. The same list is getting passed. 3. You make another call. Still the start index is not equal to it, so you make another call. Length is 5 and start index is 4. This time the SI start index is equal to length, so you return minus 1. So you return minus 1 here. Now what does this function say? This function says, okay, I have received minus 1, so I need to check if A of SI is X. SI is this. SI was this was the SI, this was the SI, and this was the SI. So you check SI here, and you see that you have an 8 here, you don't have 4 here. So you return minus 1 from here. Once you return minus 1 from here, now this call also looks at SI, which is 3, which is this index, and it says, oh, I found 4. So it's going to return whatever index you had. So it's returning 3. So this one got not equal to 0, not equal to minus 1. So whatever you returned, it's going to return the same thing, and same thing, which is the correct answer. There is a slight difference between both the function. This function returns the index as per the smaller list that you have passed. This function returns as per the index in the complete list and not just the smaller part, right? In the complete one. So if you have 4 here, this will return 0, this will not return 0, this will return SI, right? And we are handling both the conditions accordingly depending upon the function. Okay, so great. So we have written a lot of code by now. Please work on the assignment, and in the next lecture we'll start looking at a lot more interesting problems to gain a lot more confidence on recursion. Okay, thank you.